Today you're going to take some notes about perfect squares and square roots and complete this sheet and bring it to Ms. Husak in order to move on in your folder. So we're going to begin by discussing the definition of a perfect square. Right here, you're going to look and see it says a perfect square is the product of an integer times itself. Take a second to copy that down. Then we want to talk about two of the words within this definition that some of us know really well and others of us may have heard before but don't remember. First word here is product. A product is the answer to a multiplication problem. If you don't know that word very well, you might want to record this definition as well and take a couple seconds to do that. The second word that's in here that we have heard and maybe not have mastered yet is the word integer. An integer is a positive or negative whole number. So when we're talking about perfect squares, we're just talking about taking whole numbers and multiplying them times itself. That's a whole lot easier than fractions or decimals. As we look down at the boxes below, we're going to start talking about what it means when we have something like a 1 squared, right? What does that little 2 mean? Well, you know probably by now, or maybe you just need to remind yourself, that 1 squared, that little 2 tells you how many times you're going to multiply 1 times itself. So if we multiply it 2 times, right, 1 times 1, the answer to that one is 1. So 1 squared equals 1. 2 squared is the same as 2 times 2, which is equal to 4. 3 squared is the same as 3 times 3, which is equal to 9. And you can kind of go down the diagonal part of your multiplication table if you wanted to. 4 squared is 16, 4 times 4. 5 squared is 25, 5 times 5. 6 squared is 36 because it's 6 times 6. And go ahead and grab a multiplication table or another tool and fill out the rest of those. Okay, now let's talk about square roots. The definition of a square root is even more confusing, and I looked up several different definitions, and it was hard for me to find one that made a lot of sense. So we're just going to kind of take it into regular person terms. A square root is the number that, when multiplied by itself, had the product that is listed under that root symbol. So when I'm looking at these examples underneath, what I'm looking at is to see this number underneath the root symbol was created by multiplying some integer times itself. I've just got to figure out what that integer is. It's not, for example, 3 times 3, that's only 9, so it's got to be bigger. When I go through, what I'll discover is that the square root of 196 is 14 because 14 times 14 equals 196. You probably knew that already because you'd filled out all those squares up above, but remember that the diagonal line on your multiplication table will also show these perfect squares for you so that you can look for that number times itself. Go ahead and figure out the other two, and then we'll move on to the bottom portion. Okay, so now we're going to focus on this last part that says right here, for an integer that is not a perfect square. This is one of those things we practiced before just a little bit, and it's something that was a problem on the last summative. So when numbers are not a perfect square, that means that we can't look on a multiplication table to find its square root because it's not a whole number being multiplied times itself. But what we can do is estimate which two whole numbers it's between. And we can do that using the perfect squares. So I'm going to look at, for example, this first example 1 that asked me to look at the square root of 8. So there is no perfect square root of 8. If you look at your list from up above on this notes, or you look at your multiplication table, there is none. What we do know and have, however, are the two perfect squares that come one before 8 and one after 8. For example, I can easily identify the square root of 9, which comes just after 8. And the perfect square before that would be the square root of 4. So the square root of 4 equals 2, and the square root of 9 equals 3. So somewhere between 2 and 3 is the decimal that will multiply times itself and give us 8. So your job is not to find that decimal. Your job is not to punch anything into a calculator. Your job is to find those two perfect squares, one before the one given. So here was my given square root of 8. The one before it was the square root of 4. That's a perfect square. The one after it was the square root of 9. That's a perfect square, which says to me that the square root of 8 is a number somewhere between 2 and 3. So because you have a list above and you have access to a multiplication table, you should be able to go through the rest of the examples on this sheet. When you are done with that, bring it and show an adult in the room, and then you can get access to the homework that is connected to this exact activity.